Hi everyone, today I'm going to be talking about factoring out a monomial from a polynomial, particularly the greatest common factor. So here we have 6c to the third power plus 4c squared. And the first thing we're going to want to do is identify our greatest common factor. Now notice that our terms here, both our terms here, have a number component and a variable component. So let's focus on the number component first. 6 can be broken down into 3 times 2. 4 can be broken down into 2 times 2. Now let's identify our common factors here, which is just a 2, which happens to be our greatest common factor for the number part. And now let's look at the variable component. C to the third is the same thing as C times C times C. C squared is the same thing as C times C. Now let's identify how many C's we have in common. We have 1, 2 C's in common. So for our variable component, it's just C squared. So factoring is the same thing as undoing the distributive property. So we're going to put our greatest common factor out in the front here and put parentheses in between. And let's start dividing by our number component. So we have a 2 here. Well, here we have 6. What's 6 divided by 2? It's 3. So we're going to put a 3 here. What's c to the third power divided by c squared? That's just c to the first power. We're just c. And then we're going to carry our plus over. And then 4 divided by 2 is just 2. Okay, so now we're working on the second term. 4 divided by 2 is just 2, so I'm going to write a 2 here. C squared divided by c squared is just 1. So we have like a 1 here. So our final factored form is 2c squared parentheses 3c plus 2 close parentheses. Here's another problem. This time we have 3w to the third power minus 6. Again, our first step is going to be identifying our greatest common factor. So for our number component, we have 3 and 6. Well, 3 is just a prime number. It can only be divided by itself and 1. 6 can be broken down into 3 and 2. Let's highlight our common factors here, which happens to be just a 3. So for a number component, our greatest common factor is 3. Let's look at the variable component now. Well, 3w to the third power has w to the third power. And that's the same thing as w times w times w. Well, how many w's does the minus 6 have? None. So do they have any w's in common? No. So our greatest common factor is just 3. So we're going to kick that out in the front and then write our parentheses. Okay? And now we're going to divide. 3 divided by 3 is just 1. 1. So I'm going to write a 1 here. And then we don't have any w's to divide by, so that will just stay in here. We're going to carry our negative here, and then 6 divided by 3 is just 2. So our final answer is just 3 parentheses w to the third minus 2. Here's another problem. This time we have 8k to the third power plus 16k squared. Again, we're going to identify our greatest common factor first. So here, our number component, we have 8 and 16. So 8 can be broken down to 4 times 2. 4 can be further broken down to 2 times 2. 16 can be broken down into 8 times 2. The 8 can be broken down into 4 times 2. And the 4 can be further broken down into 2 times 2. And now we're going to look at our prime factorization here and identify the common factors. It looks like they have 1, 2, 3 2's in common. And we're going to multiply our common factors here. So they have 3 2's in common. That gives us 2 times 2 times 2, which is 8. So for a number component, the greatest common factor is 8. Now let's look at the variable component. K to the third is the same thing as k times k times k. K squared is the same thing as k times k. How many k's do they have in common? Well, they have 1, 2 k's in common. So for a variable component, it's just k to the second power. So we're going to kick our greatest common factor out in the front and write our parentheses. And now we're going to just divide each term. 8 divided by 8 is just 1. K to the third, we're going to look at our terms here, divided by k to the second power is just k to the first power. So that's just k. And now we're going to do this, and then we're going to carry our plus sign, and then we're going to do the same thing with our second term. 16 divided by 8 is 2. So I'm going to write a 2 here. K squared divided by k squared is just 1. So there's just really a 1 here. So our final factored form is 8k squared parentheses k plus 2. Let's do one more problem. So this time we have 7n plus 18. Again, we're going to look at our number component. So for 7 is a prime number, so the only factors that go into it are itself and 1. 18 can be broken down into 9 times 2. 9 can be further broken down into 3 times 3. Do we see any common factors here? No. Well, except 1, right? Because 1 divides into anything. So for our number component, it's just 1. Well, 7n has an n, but 18 doesn't have any n's at all. So do they have any n's in common? No. So our greatest common factor is just 1. And if our greatest common factor is just 1, we just have to retype the polynomial.